Okay. Alright guys, and welcome back to another video. This is episode number 4 of the low poly racer, and I know you've been waiting quite some time for this one, and so have I. First of all, my wife had a birthday, so that was really nice. We spent that together, and I've done the Ludum Dare in the meantime as well. That was a lot of fun. Ludum Dare 46, check out my game, a little alien rescue. And I also did the Rigify video, so if you haven't seen that one, you should have a look at that one. And I've done the usual 10-minute modeling videos, as well as working, of course. Got a full-time job doing an RTS game now. It's a lot of fun. One more thing, I've changed it up a little bit because when I made the low poly racer, I did a lot of things back and forth. I changed them around and then I changed it again and again while I was testing to develop. I usually do that when I prototype a lot. And instead of having to drag you through that entire process of doing something and then changing it back and then doing something and then changing again, probably going to be a lot of confusing. So what I did was I tidied up the project a little bit and I restructured some of the code and the hierarchy of things, and then I've scrapped that. I've put that to the side, and I've got a project now similar to where we left off last time. So I've only got the basic track and the little police car, but I have to I'll take you through writing the scripts again, and hopefully it should be a little bit of better code. I have to warn you though, I'm not really the greatest of programmer, so you're gonna find a lot of stuff that you can make more efficient and more straightforward and definitely more object oriented. This is to my ability. I'll do something that should be hopefully easy enough to follow along and also easy enough to do. And again, performance is not going to be an issue for a game like this, so I'm not too worried about that, but the reusability of code and things like that could be improved. But let's see where we left off. Pretty much I've got the car here, as you can see. If I press play now, nothing will really happen because I even scrapped the input script. So we'll redo a little bit of that, and we'll also redo a bit of the wheel collider stuff. And if you remember it, if I expand this car here now, where we left off, we had a bunch of transforms and also the wheel colliders. So instead of doing that, I thought I'd simplify it a little bit. So let's move these, I'll shift select these and just drag them into the root here of the wheels. And then we can delete this wheel collider one altogether. And then what I'll do as well is I'll just drag these are the actual wheels here, the transforms. So I'll drag those instead as children of the wheel collider objects here. And then we'll delete that one as well. So all we have now, if we do this, is let's collapse and expand. We just have wheels, and then we've got the 4 wheels here. And then this has just got the wheel collider for now and nothing else. And under here we have the mesh as well. We can just rename this one F2 and put mesh here. Let's do that for all of them actually. If I hold the Alt key, it'll do it for all of these. So let's just do mesh, mesh, and mesh. So maybe that's a little bit better structure. We have the copy car here, and we've just got the wheels here. And then we've got the colliders that we set up before, and we've also got the center of mass transform here. Someone suggested as well, which is actually quite handy, and that's on this mesh here. It's scale 1 here, but on the other mesh here, the right front, where one trick to do is to just do -1 here on the X scale, and that'll keep the code then the same. We had to do some tricks before when we did set the position. So there's a little trick. Thanks for those of you who suggested that. So both the right wheels here, the meshes are flipped on the x-axis here as -1, as you can see. Again, like the car isn't moving because if we go into the script, I took away some of the input code and some of the wheel alignment code. And let's change this around a little bit to make it more reusable anyway. The first thing I'm going to do, I'm going to create a new script here, and I'm going to call it wheels, or just wheel. And in this one instead, we'll set some properties here for it. So let's do a public bool steer. That's just an on-off flag if we want to steer the car, or steer this wheel in particular. We'll do invert steer as well, because sometimes if you have rear wheels on a car that you want to steer, like a forklift truck, for example, you might want to invert the steering so it turns the other way. And we also want to set the power that could be applied to the wheel. So if it's a rear wheel drive, for example, or a 4-wheel car drive. So also, it's not really best practice when you do programming to expose variables public, you can actually do them private and then expose them to inspector. But then Unity will warn you that they're not assigned a value. So I'm just going to keep it really simple now. I'm aware that you shouldn't really expose public variables like this, but it's the simplest way if you want to get the job done. And it's not really that much of a problem. Okay, what else do we need? We need to set the steer angle. So we'll do a public float here and call that steer angle. And then we'll make this a property, so a get set property. And this way it won't be exposed in the inspector. We'll also do a torque here, get set. So this is just a public property that we can set. So let's add a couple of private variables here as well. We'll do a private wheel collider. Call that wheel collider. We'll do another one called transform, and this is for the wheel transform. And instead of assigning these in the inspector, let's make the script automatically grab these. So we can just assign them here in the start mono behavior. That'll start up every time Unity starts up this component. This will run automatically. So we'll do wheel collider. That's this private variable that we assigned here. And then we'll do get component in children, wheel collider. And now when this script starts up, it'll look in the transforms child hierarchy and see if it finds a wheel collider. And if it does, it'll assign that to this wheel collider variable. So we don't have to assign that in the inspector then. This will just pick it up automatically. So if we're adding a lot of wheels, it'll save us the hassle of having to drag that. And the other one we'll do as well, wheel transform equals get component in children. And here we have to grab the mesh renderer instead. And then we'll get the component transform. And the reason why I don't get the transform to begin with is because the first child will actually, it'll have a transform as well. So I can't just grab that one, you'd grab the same one as the wheel collider is. So that's why I'm looking for a mesh render in this case, because I know that one child will have the wheel rendering, and that's the one I want to grab the reference to for the transform. Then what we'll do is just swap back here. And then to these wheels now, we'll just drag this wheel component, and that automatically assigns it to all of them here. And then we can set that the two front wheels here, they're going to be steering wheels, and the rear wheels here, they're going to be powered wheels. So the reason why these pop up here is because we exposed those here in the inspector, but we didn't really get the steer angle and the torque, and I'll set that from elsewhere. That's why we set those, if you remember it, that we set those as properties here, the get set here. If you don't know what properties are, maybe do a quick Google search on properties in C#. So with that said, we also need to, in the update, if you remember the last script that we made, then we had to get the wheel collider to set the rotation and everything of the transform. Okay, let's just press play and see what happens now. Nothing will really happen at all, apart from it still doesn't listen to any input like what we had before, and the wheel colliders are just sitting here not doing much of a job at the moment. All we've done is just add a script to prepare for things. We should actually start doing the input now as well. Okay, we're still just catching up to where we were before really, but let's add a little bit more code in this wheel one now. The update method here runs every frame in Unity. And if you remember last time, we put some code where we had to get the wheel collider to send its position and rotation to the transform. So that's what we have to do for this new wheel component as well. Let's do, in this update, let's do wheel collider get world pose, and then we'll out that into a vector 3, which is called pos, and then out the rotation, which is a quaternion, to rot. And then here, let's do wheel transform. We need to set now position. We'll set it to the pos variable. And the wheel transform rotation R. And then you can just press tab in Visual Studio to get it to autocomplete, the most likely one. So equals rot. And then we also need to do some stuff in fixed update here. So update runs every frame, and if you have normally it'll run at 60 frames per second if that's what your monitor is set to. But you can also, people might disable the VSync, and they could run at even 1,000 frames per second. So this update loop runs really often. And there's another one that is called by Unity every fixed update, it's called, and the physics engine runs at 100 Hertz by default, so 100 times per second. So this fixed update will be called 100 times per second. And now we'll do if steer. So we'll check if this is a steering wheel, not a steering wheel, but a wheel that steers the car. So if that one's set to true, then we'll do this wheel collider steer angle equals steer angle, which is this property that we're going to set from elsewhere. And then we'll do a check if we've enabled invert steer. And here we'll do a shortcut for an if statement. So it'll check if invert steer is set, then it should do -1. And if it's not set, then it should set it to 1 here. And that's just basically to flip the steering angle if this bool is set or not. And then like we did with steering, let's just do with the power as well. We'll do if power. So if this wheel is about to apply power, then we'll do wheel collider motor torque equals torque. And that's it. That's our complete wheel script now. And it's still not going to do anything when we press play, because it's basically it just sits here and it's waiting for input now. So nothing is really happening. And for that to happen, we need to start making an input controller, so we can start listening for the keys. And I don't really want the car itself to listen for keys like I did before in the previous example, because I want to be able to reuse the car so an AI could be able to drive the car, for example. So instead, we'll first of all, we need a game manager. So let's just create an object here called game manager. Yeah, that's right. And then we need one more script here, and we're going to call this input manager. Or we'll call it input controller, actually. Okay, and then we'll double click on this input controller. And here we'll do some more universal code now for that the game can listen to your input. Instead of the car doing it, we'll make this input controller listen to all the input. So we'll do, first of all, we'll do a public string here that we'll call input steer axis equals horizontal. And this is the default. If you look here in Unity, we can go to the edit, project settings, input. You can see that there is a bunch of predefined variables here, and one of them, for example, is the horizontal axis, and that's the A and D keys that it'll listen to. And also it can listen to a joystick x-axis. And there's another axis here that we're going to be using, which is the vertical one. So you can change those around here, but I'm just going to use these default ones. So we'll do the same here. We'll do a public string input throttle axis equals vertical. So whenever you do up and down or W and S on the keyboard, it'll throttle the car forward. Okay, and then we'll do a public float here, and it's going to be a throttle input get. And another script could get this input now because it's exposed as a public property, but we'll only do a private set here. So only this script can set it. Only the input manager itself can set this variable or property. And same thing, we'll do steer input, and this is also a get, that anyone can get this information, but it's going to be a private set. Only this script can set it. You don't need anything in the start one here. In this update loop now, all we'll do is steer input equals input get axis input steer axis, and then we'll do throttle input equals input dot get axis input throttle axis. So let's recap this real quick. The only reason why I've set these to public is because you can customize those in the inspector then if you want to be able to add some more axis or change it to like a hand controller, for example. So you don't have to do that. You could keep it private and hidden if you want. But then in this update loop, all it'll do is it'll listen to the input get axis here and take the steer axis and the throttle axis and put those values into this public property so other scripts can get it. So it'll store this throttle input and also the steer input. So now we know that any input that's going to control any car is going to be in this input controller script. Okay, nearly there now. Let's also do, we created this game manager script, and that's empty at the moment, like this. But let's create a new object in our scene here now and call it, create an empty here and set it to 0. So it's in the center of the scene. And then F2 and rename this one to game manager. And then we'll drag this game manager script onto this one.
And this is an empty script, so we won't do anything yet. But under here, I'm also going to create a new empty, and I'm going to call this. I'm going to call this input controller, and then we can drag the input controller script to this one here. Here you can see the public variables that we set, the horizontal and the vertical axis here. So they're exposed. You could change those to axis 1, 2, or 3 or something like that if you needed to change it to a different controller. Okay, then we go back into this car script, and we need to do a little bit of tweaking here as well. So we'll define a new variable here, and let's call this one, this is going to be an array, a wheel array of the wheel component that we created, that wheel.cs script. Just call this wheels, and then here we'll just grab a reference to this now. So wheels equals get components in children wheel, like that. So let's recap this one as well. So on this car script here, let's see what it does. It's sitting on the car here, and we've got this car script here, and under here we have a bunch of wheels, but they're further down into the Unity hierarchy here. But this one's got a wheel script, and so does this wheel, and this one, and this one. And if we look at this script again, what does it do? In the start mono behavior here, it'll look for all the components in its children and find this wheel component that we're looking for. And then it'll return all of those and put those into this array of wheels. And this way we could have a car with an 18-wheeler truck, for example. It'll grab all of those wheels and put them into this array here. And now in the update, all we need to do, instead of typing the code over and over for each wheel, let's just do for each. So we'll do a for each loop for all of the wheels here. Var wheel in wheels. And then we'll do wheel.steer angle equals steer multiplied by the max steer. And we'll do wheel torque equals throttle times motor torque. So again, if we had one wheel, it'll just do it for one wheel. Now we've got 4 wheels, and it'll send the steer angle and the torque to all of those 4 wheels automatically. And this grabs the components and puts them in the array. And in the update here, it'll for each all of these wheels and then apply the steer angle and the torque. And remember that we've configured that wheels can listen or not listen to this information as well, because if it's got on this wheel here, it'll only apply the steer angle information that it gets if steer is enabled here. So if steer, that's where the steering information is actually sent to all the wheels, but it's only if this bool variable is set to true that it'll actually apply the steering. Okay, we're getting closer now. So we're still not sending the input, so still just bear with me. There's a bit of a restructure to the code. It'll make more sense later on probably. But if we press play, still nothing is really happening, but we're getting close now. We've got the basic input controller now that will listen for the input, and that's happening right now. We've got wheels that's ready to receive information for the steering and the torque. Now we just have to connect those two together and make the inputs being sent to the wheels. And now we're gonna use this game manager to, not game manager, game manager. This is still an empty script, and the only reason why it gets a cogwheel icon, you don't have to worry about that. I think it's just Unity thinking that this is such a common name for a script that it'll change the icon for it. But it's still just a C# script like any other here, so it's the same. Let's go into that one, and here we're gonna just make sure that other objects can call this one now, and we're going to make it into something called a singleton. And if you Google singleton, the whole internet will scream at you and say don't use it, but all the alternatives are a lot more complicated to get into, all the other design patterns. So I think if you're not sure of how to do other stuff, this is a good way to start it, because make a simple game, learn the simple parts first, and then learn more object-oriented languages and better design patterns later on. In our RTS game, we're using dependency injection instead, which is a different pattern that you could use. And but just to keep to the simple stuff, let's make this one a singleton, and a very basic one as such. So let's just, if you're gonna do some hate in the comments, feel free to do so. We're gonna use a singleton anyway, and we're gonna do this quite simple so everyone can follow. All right, so we're gonna make it possible for other scripts to, regardless, they're gonna be able to find this script without having a reference to it. So we'll do a public static variable, and it's gonna be a game manager variable, so same as this object. And then we're just gonna call this instance. And it's going to be a property, so others can get it, but only this one can set it. And we'll just do in the start here, we'll change this to awake. And here's another concept. I'll go through this in awake. I'm going to do a video where I go through all of these concepts more in detail about the different mono behaviors like awake and start. But for this purpose, awake runs before start. So it'll run awake on all the scripts first. Once it's done with that, it'll run start on all the scripts. And then it's just basically like a multiple staged rocket where you can put types of scripts in the different stages. And we want to make sure that this happens as soon as possible. So it's going to happen when this object is awoken. And here we'll just do instance equals this. And that's the most simple type of singleton that you can do. And others can find this script now by just referencing this static variable. But you have to be careful, because if you added this game manager to multiple objects, it won't work. You can only have one game manager, and we're not really protecting ourselves from that in the code. But just to keep it simple now, I just want to keep it like this. For a lot of you, this is probably weird enough just as it is. So I'll just keep it very simple at this point. The input needs to reach from the input controller that we've created to the car's wheels. Ultimately, that's what will need to happen. So here we'll do a public input controller reference, or a property. We'll call this one input controller. Others can get it, but only this one can set it. And then what we'll do is here in the awake mono behavior, then we'll do input controller equals get component in children input controller. So this one will, as soon as it starts now, it's going to look in its children and it's going to see, I want to get a component called input controller, and I want to store that in my property here that others can use. So when this script runs in the startup or in the awake here, it'll look down in its hierarchy and it'll find, oh, I've got an input controller here and it's got this script to it. I'll create a reference to this one. So finally now we can use this in other scripts. So if we go back into the car script now, I'm actually going to move this code elsewhere again, but just to keep it really simple in the beginning, in this update loop here now, we'll just do steer equals game manager dot instance. And here's where that singleton comes into play, because we've referenced the static variable, or we've got a static variable now called instance, and that one will return the only instance of the game manager that we've got. And this one in turn has got the input controller that we configured. And then we've got the steer input. So if we look here, this script will go, oh, game manager. That's a component that we've created, or a script. And that's got the static property called instance here. So if we go back in the game manager, we've got a static instance manager here. We've got a static game manager instance here. So back in the car script here, we found the game manager, we found the static property instance, and now we want to find the input controller. And that's set here in the awake. First of all, we set the instance to this, which is this component. And then we've added this input controller now. It's found the input controller in its children. So now the car can find that one in the scene when it starts up. And it can actually find this all the time now. So in the steer, it'll just get the steer input and store that into its own steer property here. And then we'll do throttle equals game manager instance input controller dot throttle input. And the reason why I made these properties of the car script is because I'm going to break this out into a player script later on, because you don't necessarily want the input manager to send the information straight to the car. What if an AI is driving this car? Then you want to have a different component sending that. But just to test this finally out now, after a lot of talking here, this is probably going to be the most disliked video of all, because I've just spent a lot of time writing script where nothing's happening. But now when I press forward, the input manager in the scene will listen to the input and it'll apply that to the car, and it'll apply it all to the wheels. So that was a lot of code now, so I should probably recap this one because it's a lot of stuff to take in. So if you want to fast forward, I'll put in the description, I'll put some timestamps a little bit. But now let's recap, what did we actually do here? So first, from episode 3, what we did is we moved into a simpler hierarchy here. So the wheels with the wheel collider is just here in a wheels subfolder or subgame object, and we've got the left front, left rear, and right rear. That's just got the wheel collider on it, and it's got the wheel script that we've created. Okay, and under this one, we've got a mesh one, and this has got the mesh filter with the wheel mesh on it. It's got a mesh renderer that renders the wheel. And then here we've got, so that looks the same for all of these wheels. But what we did differently now, and a little bit better than we did before, is that we actually added this component, the wheel script. And let's bring that one up. So the wheel script has got, it's got 3 public variables here. And we can configure if a car should be able to steer with this wheel, if the steering should be inverted, and if it should be powered, this wheel. If we look back here now, we can have the different check marks. What if I just unchecked the steering now for these 2 wheels? Can you guess what will happen? You guessed it, can't steer it. I'm pressing the keys now, nothing's happening. On the real wheels now, let's just enable steering here. So what happens then? It's sort of like a forklift truck now, but not, because now I press left on the key, but the car goes right. So if this was a forklift, you'd drive yourself mental because it'd go the wrong way the whole time. So we can invert the steering here on both of these. I've got both selected. And now when I steer it, it'll be like a forklift truck where you steer with the rear wheels instead. Okay, but let's bring back, so we've got just power on the rear wheels, and on the front wheels here we have steering. But what if we add power to the front wheels as well? We'll have a 4-wheel drive car. It'll accelerate a lot faster and be a lot more rapid. So made it, by breaking this out into a separate script now, it made it a little bit easier for us to customize the wheels. And we could have 6 wheels, 8 wheels, 20 wheels, 18 wheels, whatever you want. And you can just configure them as you need instead. Okay, so that was one of the things that we did. Okay, we also simplified the wheel a little bit by the wheels themselves will look at the wheel collider's configuration, the position and rotation of the wheel, and it'll set that to itself or its own transform. It gets the component here by looking for a mesh renderer, and that way it finds the actual visible wheel on the car, and it gets the transform component on that one. And then in its own update loop here, every frame, it'll look for the wheel collider's rotation and position, and then it'll apply that to the transform here. And that will do it. No matter how many wheels we've got, we don't need to repeat this code anyway. And then in the fixed update here, if its steering is enabled, then it'll send the steer angle that it's received from somewhere, and it'll send that to the wheel collider. And same thing for the motor torque. It'll see if it's gotten any torque sent into it from anywhere, and if it's got that, then it'll apply it to the wheel collider. And it's the car that sends this information at the moment. We can actually get somewhere else can set this steering angle and the throttle, but at this point it's just the script doing it itself here in the update. But it receives it from the game manager instance input controller's steer input. And then it'll get the steering and the throttle here from the input controller, and then it'll loop through all the wheels that it knows about, and it'll send the steer angle and the torque to those wheels. And here's the reference. We've got a private array here of the wheel component or wheel class, and then in the start here it'll look for all the components in its children, and it'll find those wheels and assign those into here. That's why it works to loop here, and then the car can send this steer angle and the torque. And let's recap as well. We did a simple input controller that listens to input from the horizontal and the vertical axis, and it just stores that into this these 2 properties that someone else can look for. So if we had 10 cars, actually let's do that now. This is where this comes in a little bit handy. If we made it a copy of this car now, just Control D on this one, send it to the side here a little bit, and without changing any code now, both of these cars will actually receive the input automatically. So they'll steer together and they'll roll over together. Okay, the car drives out of view now, so let's create a simple camera script now as well, so we can follow along with the car. So let's right click here on in the scripts folder, do create C# script. Call this one camera follow, and here we'll just set public transform target, and then we'll do public vector 3 offset, public vector 3 Euler rotation. Thanks for correcting me. I've always said Euler rotation, but it's called Euler rotation. And then we'll do a damper here as well. So public float damper. And then here in the start, we'll do transform Euler angles equals Euler rotation. And here in the update, let's do if target is null, then we don't want to do anything, so let's just return. We don't want to continue in this loop. But if the target is set, we'll do transform position equals vector 3. We'll do a linear interpolation from its current position here. So from transform position to target position plus the offset that we've configured. And then we'll do it damper times time.time. And this way it'll smoothly follow the car to whatever we've configured it to. So we can do here on the camera now, on the main camera, let's assign this component. We'll just drag it onto the main camera here, camera follow. And then we'll drag this copy car here to the target. And then we need to configure this as well, so we got some values. And to figure out that, then you can look pretty much at what the camera's current position and rotation is. If we move this car actually back to center scene, so we know it'll be easier to do the references here. But we don't really see the car now because it's under this here. It's under there. But that's okay. We want to see where do we want the camera roughly. So if we set it to here, maybe 21, 38, maybe something like this will be good. The car's there, pretty much center. So now we know pretty much what we're going to set these values to: 38, 21, 62 for the Euler rotation, and 180 on the y-axis. And the damper will just set to 1 for now. And when we press play now, we should have the camera start following the car quite smoothly. That seems to work pretty good, so that's all we need to do for now for getting the camera movement to work quite smooth and nice. Okay, I should also show you that I've played around a little bit with the suspension and forward friction and the physics. I need to mention that. I don't think I mentioned that yet. And first of all, to get this into a more cartoony car game, then you don't really want the real world physics. It'll look, let's actually switch that back because I've changed that without your knowledge. So shame on me. If I go to the project settings here and go to physics, you can see that I've actually ramped up the physics. Let's set this back to minus 9.81, which is the default value in Unity. We can actually drag this one into here because we're going to access it again. And then I press play here. And now you can see that it'll behave really weird. First of all, it'll roll over there because I've got a lot of friction at the moment. But let's try to make it to this jump here. So if I launch myself on this jump now, this is why we don't really want real world physics in it. Because the speed is so much greater than you would have in real life that it doesn't really work for a cartoony type of game or a small scale game. So I've actually bumped up the friction here to minus 30. And that way we can have it, it'll make it possible to clear the jumps, but so that's why we've bumped up the physics here. And also, I don't know if I showed you this, so I have to show, I've added another layer here called wheel collider. And if we look here, we've got the wheels have set the layer to wheel collider. And the car itself is just another layer called car. And the reason why I've done this is because you don't want the wheel colliders of the car to collide with the car itself, or with those colliders. So in the project settings here, we go to physics. We can see this collision matrix. The wheel collider does not collide with the car. So also I've disabled it for props, so that I'll be adding to the scene as well. So the wheel collider does not collide with the car. That's why I've separated those into different colliders. And then also you should look at these settings now for the inspector if you want to copy these. Because on the front wheels, I've got, these are the trickiest things, I think, with the wheel colliders, is to set the correct or the proper settings that feels most right for your game. I can't really explain exactly what these do because I'm not so good at them themselves, but it basically controls what's the value for when the friction of the wheel should let go. Like, let's say if you're doing a corner and then it starts to lose the grip, but it needs to pass a certain threshold before it lets go. But once it lets go, then it'll basically require less friction to keep it sliding. I won't be able to go into details, but for the cars to behave like I have, if we've bumped up the physics now to minus 30 for the gravity, Then these are the wheels values that I've got for the front wheels. I've got quite high values here compared to the default because the friction is so... The car has got a lot more power than you'd normally have because we wanted this cartoony fast acceleration. And with a big gravity as well, it'll pull the car down really hard to the ground. So that way we need to bump up these values quite a bit to get it to behave so it actually gets grips and sends it, so it doesn't just do wheel spins basically. And for the rear wheels, these are the values that I've got set. I'll freeze the picture a little bit so you can have a look at those. But you can just copy these values for now, and I suggest that you start playing around with them because you might not be happy with the way it feels, the way I've set them. So you can play around with these values quite a bit to see what fits your game best. Okay, the car is a little bit front heavy, so let's this collider here I think is messing up a little bit. Let's move this collider. If we do a jump, it looked like the car was a little bit front heavy, so if we do a jump here, you can see the car tumbles forward like this. And that's because this collider, let's make sure that one's in the right place here. So we'll go to the colliders here, we can see that this one is a little bit off. So let's go to this collider here, and it'll be this one, yeah. And then slide it forward a little bit on the Z axis to there. We'll have to make it taller as well. So on the Y axis here. Again, this is not so precise because the collision will be fine. It doesn't need to follow this mesh perfectly. Maybe something like that. Let's try this. Okay, it still tumbles forward, and in that case we can move the center of gravity as well here. So this, we've got this center of mass. Let's move that one back on the car a little bit to there. Let's try this out. And that jumps a lot better. So if the car is, we still got a rolling issue here, but that's okay. So if the car is tumbling forward or flipping backwards, you can change the center of mass thing so it's in a better place for the car. So another thing we should do is, I noticed that if you rub the car against the side, for example, of sometimes when you'll scrape like a wall or something like that, the friction is really hard for it, so we'll create a new physics material here. So here, let's create a new folder called Phys Materials. And here, let's just create a new physics material. So new physics material, and let's call this car chassis. And then let's lower the value a lot to 0.1 just. And for the friction here, let's do minimum. So combines friction with another material. I'll just do the lowest value. And then for these colliders now on the car itself here, go to colliders. We'll just assign this one. Click this little padlock at the top here to get this one. This way you can select stuff here without it changing. And then we can just drag this car chassis to all of these here. So the physics material will have less friction on it now. We probably won't notice too much of a difference. Let's disable that padlock again. We won't notice too much of a difference, but sometimes when your car lands like on the front or something like that, it'll like bite and then tumble over. But this way it'll slide a lot easier. So if you land on so the chassis hits the ground, instead of it catching with the friction and tumbling, it'll just slide you instead. So it'll be a little bit more fun to play that way. Okay, let's start decorating the track a little bit now as well. So we'll put some trees and things like that in. And we've imported those before, just as the meshes here. You'll see in the project folder here, you can see that we've got a bunch of meshes. But we haven't set up any prefabs for it yet. So we can drag those, let's just drag a tree in here, or all of them we can drag in. So we'll select these 4 trees and drag them into the scene. And they'll be pink at the moment because we need to set the materials. So we've created a material before that we're going to be reusing, the common material. So let's select those, shift select them, and drag this common material onto the material. And that's our trees basically. And then we need some colliders for these as well. And we'll keep that really simple as well. We'll disable the car first and disable some of the trees. So we only have 1 tree here. And here, let's add a component. Let's create a child actually called colliders. And then the first thing we'll do is just do a simple box collider on this one. And then we can resize the Y component here, center it up a little bit, and then resize it. And then make it a little bit smaller, maybe 0.5, 0.5. Then we just have to make sure, yeah, that's pretty good. And then also what we'll do is we'll add a sphere collider here. If you were to fly up into the trees for some odd reason, you probably will in this game, then you want a sphere collider up here. So let's put that a lot higher and then resize it just the radius here. So it's to like that. And again, I won't make much adjustment to this. We can fix this later on. Let's just have something in place here so it can collide up here as well. And then I can press Ctrl C on this one to copy it, hide it, show this one, and press Ctrl V and drag it into here. And that one will share pretty much the same. It looks so similar that that collider should work for that one too. I created a different layer as well before, so if I just select all of these and change this layer to props, basically everything in the scene that's not the track or the car and things like that, I just named a layer props if we want to separate those out later on. So that's it. We're going to create prefabs out of these now, so we can reuse them a little bit easier. So in this prefab folder, let's right click and do create a new one called nature. And then here, let's just drag these trees in now, and that'll automatically, Unity will create prefabs from these automatically. And a prefab is a reusable object that we can use again and again. So if I delete these from the scene now, a really handy thing now is that we can just drag these trees in, and since it's a prefab, it'll detect where the base of the tree is, and it'll put it there. So even if we drag one into here, it'll detect where the collider is and put it up there. So we can just drag a whole bunch of trees into the scene now. Now we've got some trees there. If you don't want the mesh to show through like this, there's a quick fix for it. The real-time shadows are a little bit, for hard edges, it doesn't do so great of a job. But we can actually change that. If we block select all of these, and then on cast shadows here, just do two-sided, and that'll cap those whole. You can also change the threshold, but there's Unity's got a little bit of a problem with that as well. It'll create some artifacts. So this way it'll be a bit more expensive because it'll have to basically render the two sides of the material. If performance is an issue, try to solve it some different way. I'm happy with just setting the materials to two-sided for now. Let's under props here now, let's just create a new folder here called trees, or a new game object, but we'll treat it as a folder. And I can just shift select all of these and drag them into trees here and keep it a little bit more tidy in our hierarchy here. So that's the trees done. We should also bring the tire stacks in. So let's go back into the meshes here, and then let's grab the, let's see, we can bring in stones actually. We need this. So let's bring all of these stones in just like this. And for this one, they'll end up here in the center of the scene. Hide the car again. Multi-select these and drag this common material into the material. And then here, let's just add to all of these, we can actually add just the mesh collider, because these will, and then make them convex because the shapes are quite simple. So now we've got a bunch of stones there. That's good. And then we'll just make prefabs out of these. Actually, we need, on this one, we need to have a rigid bodies as well. So add component, rigid body. And then we can set the weights of the stones here as well. So let's just set it to 200 kilograms or something like that. And now let's create prefabs out of these as well. So let's just drag the stones one by one. Unfortunately, you can't multi-select them and drag, so you have to do them one by one. And that's it. We can delete them from the scene there. And now we can just start dragging a lot of stones into our scene the way we want to place them. Let's put a whole bunch here, for example. And you can scale them. If you press R, you can scale the stones here. So let's just throw a whole bunch of stones in here. You can put some on this side as well. So now that we're gonna, let's try it out. So let's press play. You can see that the stones really flipped out a lot, and they flew all over the place, and that's because I've placed them into the ground. You can see that half the stones are in the ground. So we can start by just selecting the stones and lifting them up, and let's put them in the air for now, just slightly above the ground like this. So move these up a little bit as well, and out to there. And these stones as well. Let's just make sure that they're not colliding with the ground anywhere or the track. And Unity is going to help us to place these stones a little bit. So again, let's just make sure that they're not touching each other or the track or the ground. Okay, and now let's zoom out and let's press play and see what happens. So Unity drops it down. It uses the physics engine here to just drop it into place. And if we pause the game now, we can do something quite nifty. We can just select all of the stones that we've done, press Ctrl C to copy those, and then stop. And let's just do something scary now. We'll block select these and do delete on them. So now they're gone, but we've saved them in the Ctrl C. We've got them in memory. So now I do Ctrl V, and then it'll put those ones back, and it will have placed them now in the correct position. Yeah, unfortunately you lose the prefab reference to it, so it's not maybe great for everything, but for the stones to be placed, it's quite handy. And then here, let's create a new props folder here. Call this one stones, and then move the stones into there. So now we've got a bunch of stones on the track. Let's enable the car again and have a little look if we can collide with them. There we go. We've got stones now, so we can collide to. The next thing, you could increase the weight of the stones if you want to have them a little bit stiffer, or you can make them different weights for different sizes and things like that, but I'll just keep it like this for now. We can do the same now with the tire barriers. So if we go into the meshes here, props here, we have a tire stack. Let's drag that one into here, to the scene. Let's put that at 0, 0, 0 as well, actually. And hide the car again. And then we'll do the car wheel or the tire here at the same time. So let's bring that one into here as well. 0, 0, 0. Bring it up and in a little bit so we can see it. And now we need to assign the materials to these two. So we'll shift select and do common material. There we go. And for this one as well, for the tire stack, let's add let's add a mesh collider for this one as well and do convex. I'm just going to stick a box collider on this one so it doesn't roll all over the place. They'll stop quite fast and they'll behave a little. You don't see the collider, so if you want to change that to a different type of collider or with a cylinder or something like that, that's fine. Now we have to add some weight to these as well, so let's add the rigid body to these two. And the weight maybe of a tire stack could be 500 kilograms, so they're a bit tough to drive into, and a car tire maybe 5. And then here, if I usually enable interpolation here to interpolate as well. And we should do that to the stones here as well, actually. Stones. And the reason why I do like to do that is because sometimes you can get a little bit of a choppy effect that the objects seem to stutter a little bit. That's because they move at the physics rate, and that's not necessarily in sync with the update rate. A trick there is to just enable this interpolate, and Unity will transition those movements a lot nicer, so it'll be quite smooth. Okay, so we've got our tire stacks here now. We'll create prefabs out of those as well. So let's just drag the tire stack here into here, prefabs and the tire as well. And now we can start placing these objects as well. So maybe in this corner here, let's just drag tire stacks. Let's hit these and see what happens. There we go. That's good. And we can duplicate here. We don't need to take them from the project folder all the time. We can take them straight here from the zine. Just do Control D. And then let's scatter a bunch of tires here as well. So let's just bring a tire in here. Let's go crazy here. We'll use Unity again to help us place these. So I'll just press Control D and put a whole bunch of them here. And then we can select here, multi-select, Control D, select these again, Control D. Like this. Let's put a whole bunch over here as well. And here and there. And let's press play. And let's have Unity place those neatly for us. Pause it. Select all of these tires now. And that one. Control C. Press play. Delete these. Again, it's a shame that you lose the prefab, but it's quite nice to not have to place all of these manually. So We can remove these a little bit as well, so they're not all in sync. Put a bunch of tire stacks here as well. I'll grab that on, Control D, and slide it down to this corner maybe. This is different from Blender. It's actually, instead of Shift D, it's Control D here in Unity, and it's E to rotate, not R. So those R to rotate, you have to reschool yourself for this program. So let's move Control D, R, or E to rotate. That's gonna mess people's minds. Sorry about that. Control D, W to move instead of G in Blender. Okay, and then let's grab a whole bunch of tires here. Control D. You can spend a lot more time and make this a little bit more precise than I am, but I'll just do this a bit quick now. And you can switch this one to center if you want to rotate the whole stack like that, which is quite handy. Control D, Control D. Called, let's call them a new game object here called tires. And select all of these stacks and the tires and then drag them into this tire. And these as well. And these. That's it. Okay, we press play again. Just double check that everything looks all right. Here's a thing that you'll probably run into. See how those tires just blasted away? If I drive here, pew, it shoots those tires right out of the sky. And here you have to change. So light objects like that, then that's why I actually created a layer called props here. So let's go into this, all of these tires here. Shift select them all and put them into the props layer. And actually I'll do that for these two prefabs as well. Props. And the reason why is because in the project settings here, I have disabled the collision between the wheel collider and the props. It's because it's not really coping with such light objects. The wheel collider puts some tremendous weird force on it. So now it should be fine. You don't really drive over those now. As you can see, the wheel collider, you can't really drive over the wheels as such. But we just have to keep it like that for... otherwise we can't have it flipping out like that, so that's a limitation as far as I know. If you know of a trick how to get that to work properly, let me know. Okay, the final visual aspects that we're going to do is we're going to put the fences up now, and let's drag this fence here into the scene. There we go. And we need to do this fence post as well. We can move that one to there, and then let's select these two and get the material. So we'll drag this common material here. Okay, so we need some colliders on these. So let's just go here, add a box collider to this one. Make it a little bit less high so it clears the ground slightly. Move it up. Same for the fence post here, add a box collider. And then we need rigid bodies on these. So add rigid body, and let's put them at maybe 20 kilogram with interpolate on. And here we're going to do a trick as well, because if we just press play now, you'll see that these will fall over just like that. And we need to anchor those a little bit to the ground. We can move them to the side here and test this out. So for this, we're going to add a component here called a fixed joint. And let's just set these values here to like 200,000. And now they should be into the ground, they don't fall over. So if we enable the car again now, you can drive into this fence a little bit and it'll keep you like from going through it. But if I go fast into it, okay, I need to go even faster. So gain some speed here, pow, then it breaks. So the fixed joint will help your fence to keep the cars, help it to not drive off this ledge here, for example. But it'll, if you go too fast into it and hit it straight on, it'll break loose. So that's how you control that. So let's create prefabs out of these as well. Let's hide that one, put them back into 0, 0, 0. And here, let's just create prefabs. So we'll drag, oh yeah, I have to do one by one. So we'll drag this fence post into here. It's not in nature, is it? So there, and then the fence itself. And now we can start, we'll delete those. Now we can start placing the fence here. So we'll just drag the fence into here, rotate it, hold the control key to snap rotate. And then we do control D. And we're only using, as you can see, we have the fence posts like that, so they link up. Let's do a test here. Actually, let's create the whole bunch here. So we'll do all the way to here. And as we come to the edge here, we can start rotating these a little bit. So just go freehand a little bit. Control D, bring it to there, rotate. Control D. And then you can switch this to local axis. That'll help you to move it easier. Control D. Okay, and then when you get to the end here, then you want to put a final post, so we can just move this, just the fence post, rotate it. Okay, and then I'll just speed up this because I'll place a lot of fences around the track so you can see. But let's test it out. Let's enable the car and let's try to see if it helps us from going down. Yeah, it helps us there. But let's test again, see if I can break them. Yep, that works. Okay, so that's going to be it for this video. I'm going to just speed up and place these a little bit around the track, and after that I'll have to edit this video and have it out for you before I get lynch mobbed off the internet because I'm too slow with creating these. So I'll get this up and running for you, and then I'll work on episode 5 as well, where we're going to add some water, we're going to have the skid marks and the smoke, and then start bumping everything up into a little bit of a neater game as well, some lap times and things like that. I'm not quite sure which episode will contain which, but I'll keep pressing on, and glad to have you with me, and hope you're enjoying this series. Thanks for all the feedback, thanks for all the likes, shares, and thumbs up. I'm really happy about it, and I'll see you in the next video. So take care until then.